All right, so in this video, we're going to go through rational functions, which is from 6. We're going to go through rational functions, which is from 6G of your textbook. And there we actually went through graphs where we're sort of looking at, let's say, x squared plus 1 on x, sketching those things. We went through that last time. But also, there's two other ones, and that's when we've got the reciprocal of a quadratic. Okay, so let's say if I had x squared plus 5x plus 6 or something, then if I had something like this, then we're looking at sketching those. So first of all, this is an example from the 2006 exam 1, and you can see there that it's worth 3 marks. Very straightforward question. Very straightforward, should be really give me easy marks, but it wasn't done that well. First of all, if I've got 36, let's take out 2 as a common factor, which leaves me x squared minus 9, I would hope. Okay, and then what we've got is 36 divided by 2 gives me 18 on the top. Now I'm going to of course, factorize that, x minus 3, x plus 3. Now, what you need to do is you need to, if now you would do this with a pencil, you would not do this with a pen. For those of you, we know that if I had x squared minus 9, then that is a graph which is going to look like so. You can see there that we have the turning point is going to look like that. And of course here, that would be 3 and minus 3, wouldn't it? So you can see there that the intercepts, when we have a quadratic, the intercepts of the quadratic would become asymptotes. Okay, so what I'm saying is, can you see there? Now you do not have to draw the quadratic. You do not have to draw the quadratic to get your marks, of course, but I'm just trying to explain the process. Okay, just trying to explain the process. Now, they're the asymptotes. Now let's think about this. Forget about the 18 at the moment, because that's really just going to affect, or that's going to dilate it. Okay, but it's not going to change the shape. Now let's think about what over here. Okay, as I approach that, if I approach 1 over a very, very big number, that's going to be a very, very small. And is it positive or negative? It's positive. 1 over a positive number is a positive number. So, hence, now this is where, of course, you would have your pencil and you would rub that out, leave the asymptote, and of course, as I approach 1 over a very, very big number, it's going to be a very, very small number and vice versa. As you can see here, it's a very small number. So as we look over here, we never get to 2, do we? Oh, sorry, we never get to negative 3. That's an asymptote. So that's going to be approaching infinity, 1 over a very small number. So what you can do is our shape is going to be like this. Asymptotic behaviour, all good. And of course, the same thing over the other side, isn't it? We're approaching a very, very small number. 1 over a very, very small number is positive, and it's going to be like so. And there's no intercepts, is there? Like so. Now, the question is, this is where it gets a little bit tricky. Let's think about it. If I have a minimum, here we have a minimum, don't we? So over here, this was a minimum. What would a minimum become when we do the reciprocal of it? It becomes a maximum. And minus 9 becomes what? Minus 1 on 9. But what have we done? Haven't we got an 18 over there as well? So what would be the minimum? Someone tell me. So negative 2, you say? Yes. Okay, so so what we're going to say is that it's the same x coordinate, but instead of a minimum, you're saying it's going to be a maximum. Is that right? At -2. So what we're going to do is that's going to be 0, -2, and looking at it again, you apply the same thing. If I've got a negative number and I've got a very, very small negative number, when I'm dividing that through, that's going to give me this. Okay? Make sense? Done. So how do you get your marks? First of all, you don't label your asymptotes like this, do you? You need to label your asymptotes like this. X is equal to 3. X is equal to -3. That gives you 1 mark for your asymptotes. And another mark, it's actually a mark, that's for the shape. And the other mark, of course, is for the turning point. 1, 2, 3. There you go. How did students go on that? Well, let me go ahead and just quickly find that. I'm hoping that's from 2008. Let's go ahead and see if we can find it. 2006, okay. Let's have a look-see. So 2006 exam 1, I think it was question 3. How did students go in that? They probably would have done all right, I thought, because that one's on the easier side. The quadratic ones are a bit easier. Not that great. Really? Okay, look at that. 40% and 34% of students got 0 or 1. You need to be up this end, don't you? And I don't see any reason why you should even lose that 1 mark. Pretty straightforward. Okay. Now, what we will do is, there you go, that's that one done. Can I get you to go now? We've done this one before. That was the hardest one, wasn't it? Remember how we went through that one with 5 marks, 12.5% of that exam? You should already have that one done. We went through that one. I've actually gone through that one in another video too, if you can find it on YouTube somewhere. Now, I want you to skip all of these questions and I want you to go to the multiple choice section because I wanted to talk you through some other rational functions, or we could do some of these ones. This one would be easy peasy. Okay, let's do this one together. First of all, let's talk you through it. Do we need a calculator? I do not think so. First of all, it says asymptotes at x equals -4. Do you reckon that's something we can rule out? The asymptote would be at x equals 4. So we can rule out A and B all of a sudden. In actual fact, we can rule out C. So the answer is it's either D or E. But let's have a look. What would be the minimum? What would be the, when I draw this quadratic, I've got x squared. What do we have? We've got x squared. The minimum is going to be halfway between the 2 points, -2 and +4, isn't it? So here we've got sort of asymptotes at x equals -2 and over here at x equals 4. So what we have is the turning point is going to be halfway between the intercepts. Like it's going to be something like so. Now what is that? What is that turning point there? Okay, so what do we have to do? -9, we have to do the reciprocal of that. What's the answer? E, thank you. Very good. See how easy that was? No calculator, no nothing. If you start putting in your calculator, you're wasting your time. I can guarantee you. So let's skip. Oh, we did this question before, but let's do this one. Easy peasy. Do it in your reading time. This one. Actually, not this one. Sorry, this one. This baby here. Okay. Let's have a look. The trick in this question, it says here is these different values for A. What I'm going to say though is let's do this one. The first one, A, is going to be x squared plus A on x. Okay. And if I had x squared and A on x, what that's going to look like is I want you to think about the addition of ordinates I told you about. X squared looks like this. If A is positive, that's going to look like this. Would this give me this shape? How could you possibly, when I add the ordinates, think about it, when I add this negative ordinate to this, how could I possibly have something on this side of the asymptote, x squared? Can you see that? Cancel that crap out. Okay? Now, I definitely want an asymptote of y equals x squared. So let's see which one. Can you see there that C, if I divide that, that's going to give me 2x squared. So cross that crap out. Yes? Now, it could be D, it could be E. Now, we know for a fact that when I go ahead, and now over here we've got a negative hyperbola, rectangular hyperbola. Over here though, what do I have? Over here, this one here, we've got a quadratic, but then we've got a truncus. There's no way that's going to be right, is it? Okay. Do you think it is a truncus? Yeah. Well, we'll see. We'll see. But what about, okay, that's fine. Okay, what about a negative truncus then? It's not going to be a negative truncus, so it's B or D. So which one is it? Yeah, so the thing is that because we said that it can't be below that asymptote of y equals x squared, the answer has to be D. Yeah. Very good. Very, very good. Okay. Now, I'm going to get you to skip a few pages. Let's do some of these. Okay. Let's do these. Oh, it's so frustrating. We've still got that one to do as well. Okay. Let's do this one here. The graph of a function 2x minus 1 on x squared. First of all, let's have a look at this. What does it look like? Well, first of all, 2x is sort of like one with a decent sized gradient of 2. Okay, so that's 2x. And then minus 1 on x squared is going to look something like this, isn't it? Would you agree? Okay, now, first of all, the question is, does that have, how many asymptotes does it have? We've got, can x equal 0? No, so x can't equal 0, then that means that we've got an asymptote. And also, if x can't equal 0, can f of x equal 2x? No, so therefore what we can say is f of x cannot equal 2x either. So we've got two asymptotes. So therefore, we rule out A and B, and by the way, we could have easily done that without a calculator, couldn't we? This is what I'm talking about, doing it in your reading time. And if you're quick enough and think like that, you can do 5, 6, maybe even 7 questions out of the 20 multiple choice in your head. And you could use your little finger to scratch the answer. But I did. No one pulled me up on it. It's true. It's now on YouTube. But anyway. That's what you do. No, you're not allowed to. No, you're not. But I would be very surprised if you caught you out on a fingernail mark. I'm recording this. Yes. That's okay. That's all right. They can throw me in jail. All right. Now, just quickly, we know that there's two asymptotes, but first of all, it says here a local maximum and all that. You've got to, I think what you've got to do is you've got to consider, first of all, what is the shape? You could put this in your calculator though. Okay, this could be a stage you put the calculator on. Some of you might be even faster without it, because what we can do is if I do f dash of x is equal to 2, but be careful, what we've got is we've got x to the power of minus 3. We're bringing that minus 3 out the front, so that's positive 3. And then I'm dropping x to the power of minus 2, bringing that power out the front, which is positive 2, x to the minus 3. Now, if I'm letting that equal 0, that's going to give me 2 plus 2 on x cubed. So 2 minus 2 on x cubed is equal to 2. So x cubed is equal to -1. So therefore x is equal to -1. So there's a turning point at -1. So that rules out C, doesn't it? And now I guess what you need to do is is it a local minimum or a local maximum? Well, you could probably establish this from, if there's an asymptote at 2x, what can you tell me about the shape of this? Isn't the shape, in my opinion, isn't it going to be something like this? Yeah? All right, let's do it again. Let's do it again. Remember, we're doing this without a calculator. We could use a calculator. All right, let's try it again. Here's minus 1 on x squared. Okay, let's do it without a calculator because we've got to get better logically. Oh, yes, that's a rectangular hyperbola. Okay, is that better? Okay, my bad. Now, what do we do then? What do we do? I guess you can say here we can double. Can you see here we double this? So therefore, what we're going to have, and it's going to be below that line, so we're going to have something like that. That means that's going to be a turning point, and that's going to be a maximum. So therefore, without even picking up a calculator, the answer's E. Yes. All right, so the last question we're going to go through today is this guy here, and let's see if we can do this without a calculator. In actual fact, you have to, because this is a general one. If you start putting x to the power of k plus a on x in a calculator, it's not going to know what to do. But you've got to be really careful. It says that k and a are real constants. That's, yeah, fine. If k is an odd integer, which is greater than 1 and a is less than 0, a possible graph could be, in my opinion, the only way you can really do this is you need to consider addition of ordinates. Okay? Now I'm going to pause this and I want you to have a go at this. Okay, so I'm going to pause it now. Where are we here? All right, so I'm going to resume now. That's fantastic. So what Jack was just saying is that because it's an odd, then x to the k over x is equal to x to the k minus 1, which is even. Now, we know an even function when you have to the power of, and we're also told that it's an integer greater than 1. So we know that let's just say if we could have a quartic function, we could have a quadratic function. Let's just say it's a quadratic function, which goes something like this. Now, also, if we have a on x, but a is less than 0, it means that we're going to have a graph which looks something like this. So when we do addition of ordinates with it, then what we're looking for is, you can see there, we know that there's sort of going to be some turning point there. Okay, and it's going to basically be an asymptote at that thing as well. So instantly that rules out C, rules out D, rules out B, and in actual fact leads us to A and E. But if we look at E and we see that this is below the line, below the asymptote, the only one which is going to give us below the asymptote is not E. So the answer's A. And we did that without even picking up a calculator and stuff. That question could either take you 10 minutes or 30 to 40 seconds if you're really switched on. Okay? That's about it for today. I reckon that's probably enough on. That pretty much covers all of the rational functions over the last 10 years, or quite a few of them anyway. So I'm gonna stop this video there. That's really good.